Alright, so we have May 2011, paper 1, question 10A and B. So here are the questions. So the velocity in meters per second of a particle at time t seconds is given by v equals 2t plus cos 2t for the restrictions that are seen there. So for part A, you have to write down the velocity of the particle when t equals 0, and when t equals k, the acceleration is 0. So given that, you have to find out, you have to show that k is equal to pi over 4, and you have to find the exact velocity for when t is equal to pi over 4. Alright, so for part A, it's pretty straightforward. You just plug 0 in for t, so you plug that in, and you get cos 0, which is equal to 1 meter per second. So it's pretty straightforward. So part B1, you asked to show that k is equal to pi over 4. So first you have to find the derivative of the velocity. So doing this, you get 2 minus 2 sine 2t. And this is because the derivative of cos is negative sine, and you have to bring the 2 out and times it back in. And obviously the t will go away for 2t. So therefore the acceleration is equal to 2 minus 2 sine 2k. So you just put 0 in for the acceleration, and you bring the negative 2 sine 2k over to the other side. You divide the 2 by the other 2 on the other side, so you get sine 2k is equal to 1. And from there you must use the cast rule and remember your restrictions. So since it is positive, it can only take place in the first or second quadrant. But because of these restrictions, it must take place in the first quadrant. So sine of k is equal to 1 when k is equal to pi over 2. So therefore k must equal pi over 4 for sine 2k because it must be divided by 2. So this leads us to part B2, and you basically just plug in pi over 4 into your velocity equation, and since cos pi over 2 is equal to 0, you're only really dealing with 2 pi over 4, so that's your answer for the velocity, and that's it.